Thank you. Thank you. Okay, so I will try to make a security-focused talk not boring. So that's a challenge in its own. But so we're going to first try to identify the problem and then give a solution, which is not production ready, is not complete, is not the like my solution is like solve all your problems. Is a start for a discussion, which is like I think a little bit missing in this world. So who am I? Giacomo Tirabassi, work as a site reliability engineer at InfluxData. We do a DB, and we have a SaaS offering. Italian, Kubernetes in production since v1.8. I guess that's a flex. I don't know. And I love to cook, eat, travel. I guess that's stereotypes. I lived in 1 year in the US and 1 year in Shanghai. And that's it. This is my office view. Most days, I don't have a picture of me because this is much better. And this is the garden, fruits, vegetables, stuff. Awesome. It's definitely different from what I see outside here. But so what's the problem that we're trying to identify here? Is basically this one. Now everybody wants a Kubernetes cluster. Who's running Kubernetes in production right now? Please raise your hands. Who's running Vault in production? Awesome, awesome. Better than expected. Who's thinking about Kubernetes but not in production yet? Good. Who's thinking about Vault and tried some setups somewhere in some virtual machine somewhere paid by company? Yes, awesome. So everybody wants a Kubernetes cluster. That's like either you are a big company, small company by yourself because everybody talks about it, you want to try it. So what's the solution for giving everybody a Kubernetes cluster? And that's basically go and get a managed Kubernetes cluster solution. And this is basically it. You know, it works. No, but really, why? So in Influx, we have a couple needs, which is not like, okay, we can get to AWS or AKS or Google and say, give me a cluster. So we need to have multiple clusters running in multiple regions, which running in multiple cloud provider. So we can not just get multiple managed services. And we need to reduce the operational effort on our team. I don't want to spend my next 10 years running Kubernetes cluster. That's not my view for the future. And I don't want anyone to do this like in their lives. It's the same. I don't want anyone that run DBA. I don't think that's a job in the future to run Kubernetes cluster. And to achieving this, we want maximum automation. So automate all the things. This is a slide that everybody needs to put in their slide decks. So if you are a DevOps, sysadmin, the SRE, whatever this kind of like job description, for you, Kubernetes is your application. It's not PHP, it's not Go, it's not Node, it's not JavaScript. It's Kubernetes, it's your application. You need to be able to handle it. The way you debug Node and PHP, you need to be able to debug and test and configure Kubernetes. That's your job. But it's not just a PHP application, it's a critical application. So basically this is like, if you like, it's magic, but it's not really. So a little bit digression on automation, just like running a stateless application automate a stateless application, it's easy. We did it before, Kubernetes containers, all of these things. You can just spin up AWS instances or even bare metal, it's easy. When you talk about automating a stateful application, then it gets a little bit harder. How do you do automatic backups, rollups, upgrades, rollbacks, and all of these? It's pretty hard. And then we have critical application needs some milk because Kubernetes is a critical application. And what my definition of a critical application, even though it's not like you cannot find it in the dictionary, is an application that runs other applications. So if Kubernetes doesn't work properly, then all of the other applications running on top of it, then they're not running properly. Actually, Kubernetes does a pretty good job of isolating the control plane things and the data plane. So even if your control plane is not accessible, is broken, something, most of the time, if you did your job right, the applications are not affected for a while. So when you automate, things get hard because you get from having secrets, which are like usually when you did this job before, you had like TLS certificates were lasting 3 years. Now you're going to automate this, so you want to certificates which are short-lived. How do you observe something that always changing, always adapting, always um, people are always using it, so people are going to break it. How do you test upgrades? How do you test rollbacks or roll forwards? And like, do you know all the things that can go wrong when you deploy a Kubernetes cluster, or when you upgrade it, or when you downgrade it, or when you do some change on your underlying network? No, it's impossible. There are too many ways. There are too many things that can go wrong and can change. And you cannot just stay there and stare at dashboards all day long. So it's pretty hard. And to solve this problem, we use immutable infrastructure. I think as an industry, we skipped over immutable infrastructure as a concept pretty early on because we think, oh, we need immutable infrastructure, and then we got containers, which it's immutable infrastructure for your applications. Now we need to apply that principles just one layer below, which is virtual machines or bare metal, to manage Kubernetes. This is using immutable infrastructure principles. It's the only safe way of managing a Kubernetes cluster on your own. And that's what basically like I'm not trying to understand, like to rewrite everything from scratch. Google GKE does this for their nodes. It's just rolling new nodes every time you try to do upgrading. I mean, if Google does it, I guess we can do it too. And when you deploy Kubernetes by yourself, you need to handle a lot of things. This is like the reason that the first slide was there in the first place is that like what's the cost of managing all of these compared to clicking and getting a GKE cluster or EKS cluster, even though it may not fit all your needs. Like what's the trade-off of running that against managing all of this? So you have to manage etcd, PKI. How many people run their own PKI in their infrastructure? One person. Okay. There is a reason for that. And you have to manage nodes, upgrades, control plane, and upgrades in the nodes. And then configuration changes, and then disaster recovery and business continuity. So there is a lot of things to manage. And so this is basically like, where are my certificates? There is a lot of it. And what can actually go wrong when you manage all of these things? So this early summer, there was an audit on the Kubernetes software itself. I think it was like version 113 something. And they found 5 high critical vulnerabilities, and two of those 5 are related to TLS. Then there is like certificate expiration is a problem. Like in the previous job at the consulting for Kubernetes, and companies just called us just because their certificate were already expired. So when you deploy a cluster with kubedm, you get certificates valid for 1 year. If you don't do anything during that year, after the year, your control plane is gone and you cannot access it anymore, and you need to generate a new certificate. And that's like, if you don't know, like 1 day, 1 second, it works. And the second after, because of X509, doesn't work anymore. So if you don't do monitoring properly, then it's etcd data dump is also like a problem, because if you don't care too much about your etcd data, you can just dump that and you can get a lot of information about your infrastructure. If you don't configure the cluster correctly, no matter what you do, if I have the ability with Airbag and all of the Okta things, if I have the ability to create a pod in the cluster, I can just drop a new key or steal your private key information, or add a SSH key in the root directory of a node. So then I can just, if a pod security policy is what prevents this. So if you configure that correctly, a user that can create a pod only can create a pod with attaching config map or secret or persistent volume claims, but cannot mount a folder from the node disk, which is something we want to prevent at all costs. So here I explain a lot of problems that there are when you deploy your cluster by yourself and when you want to manage it all. If you want, I mean, it's always about how much do you care. If you don't care, just go and spin up 3 instances, kubedm init, and then join, and it's fine. But we kind of care. Our lives are depending on it, like our jobs, and I guess. So it's pretty important to me. So Vault is a secret management system. It has mainly three parts. It's composed. One is authentication. So it can connect to many authentication system. It can manage a lot of types of secrets. And then it can audit all of the actions against it. So it can have like a stream of logs, which says this person from this IP tried to authenticate on this with this authentication method, and this person without authentication method requested access to this kind of secret. So two parties really need access to Vault. We have users, humans, always creates problems. The two main forms are LDAP and OEDC. They already explained the same thing that was explained before for Kubernetes for OEDC. It's valid for Vault. So all of the providers which are ODC compliant, you can actually, the same way you can log in, all the dashboards thing, very good. Examples, you can do the same with Vault. So, and then we have nodes. So nodes are parts of the infrastructure, and we want to make sure that the right node gets the right certificates, credential, password, or in general secret, some confidential credential. I don't want a worker node, which is like very low on the hierarchy of importance, gets the master password for the cluster. That's not something I want. I want to be able to. And Vault is cool because you can derive access or roles from a node using the cloud provider APIs. So if I create an instance in AWS and associate a given IAM role, Vault can detect that that's a IAM role. So if I give IAM role master, then Vault can see, okay, this is a master. He has some sort of permission over my secrets. And all of these providers are supported and more to come. So human needs SSH access. Most likely you use Okta and you already have a solution for this. But what if I say that you can just use Vault and you can SSH into machine, logging into Google or like, I don't know, most people use Google Gmail for their company email or some other kind of, it's pretty cool if you can just log in into Google and SSH into a machine using that credentials. And with Google authentication, you can have multiple MFA. So you can have your YubiKey or your phone as a token. So it's much better to just have some private key on your machine. And this way, if you just remove someone from the organization, fire him or something else, just remove access from those nodes. And the UX, for me, is very important when you configure the system. The UX for user experience, it's very important because I want to be able to not do this every day. I just want to say, write like a very small documentation and people just use it. So you can just Vault login and method OEDC. This is the same thing that was done before on the terminal when Kube login or when kubectl get pod and then a window browser pop up to ask for authentication. This is the same experience. And then you can just SSH into nodes. And also human can need access to Kubernetes. This is like experimental. It's not something like, for now, just use Okta or Google or some other provider, but Vault can also handle Kubernetes authentication. The user experience here is not like, all the functionalities are there, but the user experience is not there yet. So that's something I don't think is good yet. And then we have three types of nodes, basically, that we care about, really. Yes. So we have etcd nodes, master nodes, and then worker nodes, and they're all going to get secrets from Vault. But what kind of secrets? I separate etcd and master. Most of the configuration you see are going to have those nodes which share both etcd data and master configuration. We separated that because the Kubernetes master are going to be updated much often than etcd node. Etcd cluster can stay the same version for like, let's say like a year, while Kubernetes evolves very fast and you have continuous patching. So you can roll masters at a very high rate, like every 2 weeks or 3 weeks, and you don't want to every time destroy the CD data. So it's much easier and faster if you keep that separate. And if you have an infrastructure with like, I don't know, tens of workers, having 3 additional, like 3 cores or 4 cores and a couple of gigs of RAM, I don't think that's impacting your cost of running the cluster. etcd node, what they do need from Vault, they need access to etcd server and peer certificates. So this is a PKI. And this is like Vault as a, between those or like secrets that can handle PKI management, which is very good because we don't want to manage like if there is one person in all of this room that's managing this day PKI, there is a pretty good reason. If you manage your PKI with OpenSSL, that's not a very good solution. Vault has an implementation for this, so when you create a PKI, the private key of that certificate authority is only stored in Vault, and Vault there is no API to get them back. So it's very good, it's very safe. So you can only sign certificate, but you can never get access to that private material. Control plane nodes for Kubernetes, we need access to actually etcd as access with mutual TLS. So you need some client certificates. You need access to the Kubernetes API key certificates authority and front proxy, which is used by some newer fancy things in Kubernetes, which is not important. Then you get access to service accounts. And then some, like if you want to encrypt data in etcd, then you need also access to a KMS supported. There are like the major AWS KMS, Google KMS, Azure, and then there is a plugin for this for also using Vault to encrypt data in etcd. So even if someone dumps your etcd, can read the specification of a deployment, but not the secrets or the configuration, whatever you like. You can configure whichever things you want to. The trick question before is that when I ask who's running their PKI internally, is that if you raise your hand for running Kubernetes, then you are managing a PKI because Kubernetes adds its own PKI management system built into it. So you're all doing it, and it's not the best way. If someone gets access to that PKI, to that secret certificates and key, then they get access to your master, to your Kubernetes API as their maximum power. And then you basically screw in, you recreate the cluster and move your application and rotate those certificates and rotate those passwords. It's pretty bad. And then for worker nodes, those are the least privileged things, but kubedm by default when you do kubectl exec or logs, you call the API on the Kubernetes master, and then that master calls whatever kubelet your pod is running on to get the exec or logs from the pod that you're asking for. That connection to the kubelet, it's over TLS, but the certificate is not verified. So the kubelet comes up and creates a self-signed certificate, which is not verified ever, which is not good. So in this case, we can, since we're using Vault, we can just generate certificates which are valid, and we can verify that. So only nodes that are part of our infrastructure and connected to Vault get those certificates, and that when you do exec or logs, you're most secure. Then we have static secrets because we are in the real world. We have still secrets which are long-lived. We're not in like magic unicorns and rainbows. SOPs is a tools created by Mozilla, and they encrypt data on your repository, so you can commit secrets, YAML secrets, without using GPG keys, because usually is the default right now. If you look at like how to encrypt data in your repository, SOPs use a KMS, so an API. So if you delete a user from Google or for Okta, they cannot no longer decrypt data in your repository. Which is again, you don't want to still like handle like GPG keys distributed around your organization to encrypt data in your repository, which is like some of the standard right now. So our solution, it's basically boring. I'm not using anything fancy. As most of people doing this job, they know Packer builds MEI, like immutable infrastructure before containers, to build MEI or any sort of virtual machine image, and Terraform to configure networks and deploying of machines. And then we do, distribute, we only want the user data to contain what's needed. So we can build only one kind of node from with Packer. And then if this node is a etcd node or a master node or a worker node, it's all defined by user data configuration. And then to actually manage these certificates, we use Vault Agent and console template. Actually, Vault Agent is the same binary that you run the server, just with a different CLI. And in the version, the 1.3.0 beta 1, which is out right now, still doesn't work. But as soon as this is going to be 1.3 stable, then Vault Agent will be embedded with console template. So you can actually don't want to run two different services. So you can actually template your certificates on disk just with Vault Agent. Um, so on the Vault side, we have, for one Kubernetes cluster, we have one PKI secret engine for etcd, transit engine, which assigns certificates and encrypt data, KV for like all of the other secrets, which are just KV, key value stores. And then to manage joins of the Kubernetes of the worker, we have a plugin which wrote custom, but KubeDM is not perfect because it works in like it's meant to be easy to use for a beginner, but it's not meant to be super safe. There is always a compromise, a trade-off when you work on software, and you either make it easy or secure. And we try to make it both, but it really isn't. So KubeDM expects certificates on disk. This is more like Kubernetes, so Kubernetes doesn't have like some sort of provider for certificates. It's expected on disk. But the problem with KubeDM is that it expects a CA key and CA certificates to be on disk at all times on the master node. So if someone gets access to those master nodes, again, you're screwed. And then we have a problem when you talk about on-prem and not like one of the major provider. How do we authenticate that kind of nodes with Vault? Because there is no provider for VMware or for nodes which have just, you have access to SSH nodes or bare metal machines. And also service account token, the public and private key, now it's like default RSA key. It's expected to be on disk and never rotated. So there is no procedure to rotate that key. So most likely that key is going to be the same from the beginning of the cluster until the end of the life of the cluster, which is not, again, very good. And moving forward, the idea is that KubeDM is good at managing the control plane, but not as good as managing the join, because to handle the join, first we need to handle the PKI management in Kubernetes, which is not something I want to be enabled. Second of all, to actually work, you need to enable anonymous authentication, which is something that was supposed to be disabled, but actually it's enabled if you use KubeDM, which again is something that you don't want to. So substituting Vault to join the nodes with just simple PKI, it's something that's that it's going to improve the security, and then also like trying to do this in a way that's like manageable, and the experience of the user managing it, supporting it, and using it, it's not crap. It's not easy, but that is like something that we want to do and increase usability for this. And also provide, and you can write your own custom authentication plugin. So maybe you have a plugin for VMware nodes, OpenStack nodes, or bare metal nodes, based on some sort of authentication from the APIs. To monitor certificates, because we are running certificates very short-lived. Very short-lived, it's like something you can choose. A good default is 90 days, because that's like the Let's Encrypt default to start with. I think it's a good default. You can, when you get more confident, more monitoring, more testing around it, you can maybe go down to 10 days or 5 days. But we need monitoring on it, because if Vault doesn't work, of some sort of authentication, something broken on the API, on the AWS provider, or on the agent, because just the real world is not very good, not very friendly with sysadmins. We need monitoring. So we actually need to know if something is going wrong, where it's going wrong, and how we can fix it. Telegraph, which is the agent of the monitoring of InfluxDB, can just ship data of these certificates to not the actual data, just the metadata. So how long they're going to live InfluxDB, and with a simple query, we can see these certificates, how long they have until they expire, which is something that you can also like put an alert on, and you get paged if something gets like below 3 days or something like that, which is actually everything. Nothing can exist if we don't do monitoring or observability on this infrastructure, because otherwise it's just like going blindly doing something that's more complex than you can actually handle. I want to do a couple demos. First of all, one which is really easy. This is a Vault which is running, and just want to share my experience. There is no real data here. This is a VPN running on the other side of the ocean, so not. So you can choose OEDC. There are a lot of providers. You can also use Okta or LDAP directly. We use Auth0, and we have our own login page, which is very good. I already have the session. I can just log in, and Vault has a very nice UI for a perspective. So this is just KV store. And you can see a lot of things, authentication methods. And because of my role in this, in Google, in Auth0 accounts, I have certain roles associated with my accounts, the same way Kubernetes. So authentication authorization is the same both in Kubernetes and Vault. There is a lot of similarities in those two connections. So a little bit more terminal. Right now I have 3 Vagrant machines running on VirtualBox. One is Vault running, one is CD, and one is master. The demo was to show, don't remember, very bad. So SSH, which is something easy, should be easy. Everything to configure SSH on the nodes is actually in this script. If I found it, SSH dot something, SSH dot sh, yes. So you actually only need to add a trusted user CA key. So it's a public infrastructure to log in into SSH and restart SSH, the daemon on the node. And the command to run, to actually have access to SSH, it's that is this one. It's not very friendly, but you can actually wrap it in whatever CLI you have. So it's Vault SSH, mode CA. There are a lot of modes, which the others are not good. And everything you just, this is my public key. I have a quite complex setup with GPG agent and SSH agent suite, and it still works, which I'm impressed with. So I can just make SSH, and this should work as all demos the first time, yes. And I mean, I don't know if you trust me. You should trust me. That I remove all of the authorized keys, and it's not something that I'm using Vagrant to SSH, but it's actually use Vault to do it. Now I want to show a little bit more certificates. So this is running Kubernetes. So if I do kubectl get nodes, we can see there is a master node. Should I get a little bit higher? There is a master node, so it's running currently. It's not ready because I haven't configured network, but it doesn't really matter. Kubernetes still works without even networking. But if I do ps dash aux pipe web etcd, there is no etcd process running on this machine. So how does it do? Is that there is another machine running etcd because so how does it connect? In these lots of flags, because Kubernetes binaries are basically a lot like a single binary, Go binary compiled with lots of flags. There is these lots of flags, which is just etcd configuration. I give the PKI certificate authority, and then the 2 client certificates and key, and then the address. And if I do etcd-ctl member list, I can see that the CD cluster is running. And how do I do this? Is that I have configured I configure a lot of variables, my environment. So all of the same files which are here are in my environment file. So certificates, address, and everything. And what if I want to see one of these, what it looks like? Not this one, the certificates. Now it's magic, really. Open SSL. This is the first and last time you're going to see someone doing this live on a screen. No out, dash. So this is just like a more human way of reading a certificates. So you're going to see here, I have the issuer, so it's my CA, which I configured in Vault. It's saying all of the nice things, so it's influx. And this certificate is valid. I created this today, this just before. So it's valid from 2 p.m. today, and it's valid until February 12, which is 90 days. And it's valid for, so for the common name is etcd1, there's private key, and then it's all of the other magic. And this allows us to, if I want to, also there is a CI issuer, and there's also a CRL, which is made, like when you're running a CA system, you actually want to at some point revoke some certificates, and this URL allows you to do this. So it's running a CI system, which is hard, just running a PKI. How did I configure Vault for running this? Since Vault is a API, it's just exposing API, REST API, I just write some Go code, which creates a PKI engine for etcd and writes all of this nice data. And I have a cluster, and I can have actually, what I did is actually I configured the idea is that you can run one Vault, and in this Vault, you can configure multiple clusters running in multiple providers, and you can just give a unique name to the cluster. And I'm going to run this live just to prove that. So now I've configured a cluster called acceptance, but I'm not satisfied with it. And now I feel very cocky, and I want to configure a cluster called what it is, acceptance. No, I want to configure production. So I'm going to initialize Vault for serving all of the certificates, SSH, transit encryption, and all of these nice things also for cluster core production. Tallinn. Save. And I try to exit from the shell. No. And make Vault something. USA. No, I don't remember which make I run. To do this, it's conf Vault. So it does actually simple things. I just run a binary, and I get the list. So this is the list that's running right now. So the way Vault is configured. So I have a cluster, just namespace, just to be future-proof, and then 3 PKI, just also for a future proof. So we have 3 PKI, one for etcd, Kubernetes itself from proxy, and then a KV, SSH, and transit. Transit is the one that does encryption. And now I want to make Vault. Let's call conf Vault. Does its magic, and we should see something going soon. Awesome. So now we see Vault, which is this Vault will be able to serve data and secret management for acceptance cluster and production Tallinn, and all of the same things are configured. So the idea is that some cluster you're gonna give freedom to developers, and you can actually, with OEDC provider, you can say everything in acceptance, like all of these credentials, you could just give it to them, to every developer in your company. They should be free to understand PKI and SSH into those nodes, but they're very, very far away from my production cluster. And this way you can have SSH configuration to a specific cluster, to a specific group of people, which is something that's usually very good when you want to manage a large enterprise, a lot of cluster, a lot of teams. And since it's one Vault cluster, every person that tries to authenticate against this is going to be logged. Every person that tries to SSH into a node is going to be logged. Where from, where to, logged, which your security team and auditor and compliance team is going to be very, very happy. Okay, just a recap. Let's go and automate everything. Scary at first. You're gonna take maybe production now, but like staging and acceptance cluster down for sure. That's the cost of science. Vault can be integrated in application, critical application deployments like Kubernetes or your own. And having a single source of auditing for all the infrastructure needs, it's scary from an availability perspective, but very good for anything other. So availability, auditing, and security and policy enforcement. And having one single place where you can audit and debug and see problems, and not go, oh, we have certificates in this in one password, and then we have passwords actually in the encrypted with GPG, and then we have thing SSH with Okta. All of these things are very easy to mishandle. If you have one place and you can have all of those in one place, it's much easier and better. So that's it. We're hiring. Spoiler. Come talk to me. Tirabassi, handle, GitHub, Twitter, all of the things. Questions? Yeah, another. 35 minutes. The cube. The cube.
Thank you. Maybe a stupid question. I must admit that I'm not familiar with Vault. I never tried it, but I saw the picture where there is 3 master nodes, 3 etcd nodes, a lot of workers, and a single Vault.
Yeah.
I presume that it is highly available.
Yeah.
How do you make sure it's highly available? How do you deploy it gets broken? So how do you make sure it lives and doesn't break?
Yeah, that's a very good question, because as a site reliability engineer and as like administrator, we want to make sure everything. I don't know why I didn't like assume that was like representing the API of Vault. It doesn't represent actually virtual machines of Vault. Vault open source can be configured in high availability, but is an active passive default. So there is like, you can configure, we have configured like replica 3, but actually only the same as etcd, only one server is going to respond at your request. This is why it's very important to use Vault Agent because it does caching and proxying. So if you do certificates or database management with Vault, you want to have a proxy between your application and Vault, both for resilience and for reducing the number of calls actually getting to the server. There is a lot of storage backends configurable with Vault. And you can, there are both that you can run on-prem, like console or etcd, or there are 2 more. And then there are some that are configurable with a cloud provider, like DynamoDB or Google Storage or Cloud Spanner or the equivalent in Azure, or MySQL or Postgres. So based on your confidence in the system, if you trust Google Cloud Storage to be a reliable storage system, then your Vault actually is stateless. You can just like, the whole region of AWS or Google goes down, but your storage is globally replicated. You can just spin up Vault in a different region, and all your data is still there. So yeah, it's then you can also pay like hundreds of thousands of dollars, and you can have like replicated, performance optimized, and multiple region support, depending on your budget, basically. But it's possible to run it also open source without too much damage. Just be careful. As usual, I guess that's like the default answer for any question.
Thank you, Giacomo, so much.